Here's the Math AS question that gives me a trigonometric function to solve, cosine of x equals negative 0.17, but it wants more than one answer, and it wants both answers between 0 and 2 pi. So in previous videos I mentioned that there's always two places where cosine is negative and two places where cosine is positive between 0 and 360 degrees. So if you remember the acronym, all students take calculus. One thing you know that if you want cosine to come out to be negative, that would happen here in quadrant 2 and quadrant 3. How do I know that? Because the A in all students take calculus says that all the trig functions are positive here. We don't want the cosine to be positive. And down here the C represents that the cosine is positive in this quadrant, and again we don't want cosine to be positive. In this problem cosine comes out to be negative. So we are going to want the angles that are in quadrant 2 and quadrant 3, so these would be the two reference triangles associated with those two quadrants. Now when I do the problem on the calculator, when I solve this on the calculator, I'm going to invoke a inverse function. So you may have noticed that solving trig equations has a lot to do with inverse trig functions, and one way to write it is to write cosine to the -1, which really means the inverse cosine. So what I'm doing here is taking the inverse cosine of both sides of the equation to show you that solving this equation for x is the same thing as finding the inverse cosine of negative 0.17. So here the inverse cosine of the cosine of x will simplify down to be x, and on the right hand side I have inverse cosine of negative 0.17. So you will get one of the answers for free in the calculator. If you just type this in verbatim in the calculator, you get an answer. But to understand how to find the second answer, you have to know some things about the reference angle. So for example, it turns out that whenever you take the inverse cosine, you always get an answer either in quadrant 1 or quadrant 2. That's always true. And it's always the case if the input here is positive, your answer will be in quadrant 1. But since in this example I'm doing the inverse cosine of a negative number, the answer will be in quadrant 2. So in general, whenever taking the inverse cosine function, you're always going to get an answer either in quadrant 1 or quadrant 2. But given that I'm taking the inverse cosine of a negative, I want the cosine to come out to be negative, I know that happens in quadrant 2, not quadrant 1. So I'm expecting the calculator to give me a result bigger than 90 degrees but less than 180. So let's just look at what that result is. Let's take the inverse cosine, and I am in degree mode by the way on my calculator. Make sure that that's the case for you. I'm going to take the inverse cosine of negative 0.17, and it tells me that the inverse cosine is error. I don't know why that happened. I think, I used a negative key instead of a subtract because I'm using my laptop keyboard. Anyway, if you do it right, you get about 99.78. If you let me round that to 99.8 for the purposes of the video, 99.8 degrees. Again, I suggested the answer should be bigger than 90, less than 180, and it is. So that's one of the answers, you know. One of my answers would be 99.8 degrees, except for it's asking for 4 decimal places, and I didn't do that. To find the other one, you really have to be a little bit of a detective and figure out what the reference angle is. So to figure out the angle in quadrant 3 for which cosine is negative, right? Cosine is negative in quadrant 2 and in quadrant 3 like we talked about. So to find that angle, because your angles are represented by starting with the positive side of the x-axis, rotating counterclockwise until you get to the terminal side, my angle here in quadrant 3 is going to be 180 degrees plus the reference angle. So the question is, what is the reference angle? When I did the inverse cosine a minute ago, my calculator doesn't give you the reference angle, it gives you this distance right here. So you have to be a little bit of the detective. The idea is that from here to here is 180 degrees, and the answer I got when I did the inverse cosine a second ago was 99.8. So if I subtract them just visually, what I get is, if 180 is from here all the way to here, then if I subtracted the 99.8, which is the distance from here to there, that angle, you should get the little angle in between. So take the big angle, 180, subtract off the smaller angle, 99.8, you'll get the reference angle in here. So if I did that, if I took my calculator and I took 180 degrees and I have to be careful to use the subtract key, and I subtracted off of this answer, and I don't want to do the rounded version. I'm going to hit second negative on my calculator, and second negative gives me previous answer, so I'm using the unrounded version of that. It'll give me the reference angle of 80.2. So because of rounding, you know, things aren't going to work out quite so well on this example here, where I'm writing anyway. So when I did that, what did I get? I already forgot. It was 80.2. So my reference angle is 80.2. Oftentimes that's called theta prime. So if my reference angle in here, that's this guy right here, is 80.2, this is getting a little tight in here, that means this reference angle here, this guy right here, is 80.2. So let me draw this down here since the picture is getting a little complicated. The idea is the reference angle here is the same as the reference angle there, so that's about 80.2. So if I wanted to find the other angle between 0 and 2 pi, that wouldn't be 80.2. It would be, again, you represent your angle starting with the positive side of the x-axis, rotating counterclockwise. This much would be 180 degrees, but then you'd have to add on the reference angle of 80.2. So let me do the unrounded version of that. 180 plus 80.2, that would be 180 plus, instead of writing 80.2, again, I'm going to do previous answer, that's second negative on my calculator. And if I do that, a more accurate representation is, 260.212, etc. Again, the Math AS wants 4 decimal places, so I should be a little more careful. So one of my answers is 99.8. It really was 99. For some reason I can't display both, so 99.7878 would be one of the answers, and then the other answer would be 260.2122 if you want to round to 4 decimal places. So this answer here is between 0 and 2 pi, well, 0 and 360, and this answer is between 0 and 360. Because they're having me answer my question in radians, right? They didn't say 0 and 360, they said 0 and 2 pi, I would have to take my answers and convert them into radians. So I would take the unrounded version of this and divide by 180 and multiply by pi, and then I would take the unrounded version of that and I would divide by 180 and multiply by pi, and that would convert both my answers into radians, and again keep it to 4 decimal places.